G'day folks, just a video reintroducing some concepts that we saw with simple and compound interest. Okay, so this lesson is just going to be a review of concepts that you would have seen, sort of simple interest certainly back in year 9 and year 10, compound interest you would have seen last year, so there's nothing new in today's work. Take some comfort in that. There might be new ways of writing some of the ideas that we see, but the actual work itself, there's nothing new in it, so don't panic. Okay. So let's look at simple interest for starters. Simple interest, the formula is I equals PRN. I is the interest that we actually make. P is the principal amount that we invest, or the main amount that we put up. So the idea is that when we go, we've worked hard, we've saved some money, we've now got a chunk of money, we want to go and put it in the bank or put it in some kind of investment that's going to return us interest. Okay, so that amount that we've saved, that we go up and we say, here you go, have this, put it away, I'll come back and I'll pick it up again in a couple of years. That amount of money that we originally stump up is called our principal investment. It's also called the present value. It's called the present value because it's how much we have now at the beginning. Okay, so P here is the principal or the present value. R is the rate of interest. Now it's very important that the rate of interest be expressed as a decimal or a fraction, not as a percentage. So if our interest rate is 6%, then we write that as a decimal or a fraction. We've done those conversions before. We'll see it. I'll show you that in an example we're going to look at in a moment. So don't panic too much. But we don't write it in as 6%. It's got to be a decimal, 0.06, or a fraction, 6 over 100. You can simplify that to 3 on 50. Again, we'll see that in the example. Don't let it stress you right now. And then N is the number of periods or the number of terms that our investment is running for. Okay. Now, in compound interest, it's very important that R and N agree, and we'll talk about that when we come to that as well. Compound interest, there's two formulas, two ways of writing the exact same formula. Okay, so the formula is either written as FV equals PV outside of 1 plus R to the power of N, or instead of writing FV and PV, we write A and P, so they mean exactly the same thing. So the FV here means exactly the same as the A, the PV means exactly the same as the P. They mean the same thing. Okay. So what does FV mean? Well, FV and A both mean the future value. So when we go along and we take our money and we give it to the bank, say, today, and we're going to sort of come back and pick it up in 3, 4, 5, 6, whatever many years from now. The future value is what our money will be worth then in the future at the end of the investment. Okay, so present value is what we have now. FV, future value, is what we have at the end. With simple interest, notice that the future value is not mentioned. That's because we need to work out the future value using a very simple but different formula. So over here, if we had to, we would say that, so here's our simple interest formula. If we had to work out our future value, our amount at the end, A would equal P plus I. So the amount we're worth at the end is how much we invest plus the interest that we earn. That should make sense. So if I come along and I invest $5,000 and it makes, say, $200, well then my future value of my investment is 5,000 plus 200, it's 5,200. I invested 5,000, I made 200, so my future value for simple interest is P plus I. Okay. So over here, the simple interest, the compound interest formula works out our future value. It's built into the formula and the way the formula works. So FV or A both mean the future value. P PV is the present value or the principal amount we invested, the bit that we stump up at the front. R is, again, like here, the rate of interest, again, not a percentage. Okay, it must be a decimal or a fraction. And N is the number of terms, the number of periods that we're investing our money for. Now, it's important that N and R agree. And again, we'll see what that means in the examples we're about to do. So the next time you look at me, I'm going to have a clean board and I'm going to put up a simple interest problem, a compound interest problem, and we're going to have a go at both. Okay. Righto folks, welcome back. Okay, so we've got two questions, one with Bob making a simple interest investment and one with Mary making a compounding interest investment. Okay. Now with Mary's investment, we've got two different scenarios, one where it's compounding annually and one where it's compounding monthly. Okay, so let's have a look at Bob's case and then we'll discuss that, go through that, and then we'll clean our workspace out and we'll have a look at Mary's case. So in Bob's case, he's investing $8,000, so that's his principal amount that he's investing. He's putting up eight grand to start, so his principal is $8,000. He's doing it at 7% per annum, so that's his rate. Now remember, we can't leave our number as a percentage, okay, so it's got to be changed to either a fraction or a decimal, and he's doing it for 5 years, so that's our number of terms. Okay, so let's have a look. We'll set our solutions here. Okay, well we know that I equals PRN. Our P is 8,000. Our rate, 7%, but we can't write 7% as a percentage. We've got to write it as a fraction or a decimal. So nice and simple, changing a percentage to a fraction, we just write the number over 100. That's 7 over 100. And our N, our number of years, or our number of terms is 5 years. Now, our interest is being paid per annum, per year, and we're investing for 5 years. So our interest rate and our number of terms agree in their units, right? So it's not, we're not talking about investing at 7% per annum for 5 months. Okay, that's a different kettle of fish, right? We need to change. We would either need to change 7% per annum into a monthly rate, or change 5 months rather, into a number of years. So it's really important. We're going to see how that works anyway in our next example. But it's really important that for now, N and R agree with one another. They're both talking about the same kinds of interest. Interest in the same same kinds of periods. Okay. So what do we got here? Well, we need to go to our calculator. We've got 8,000 times 7 over 100 times 5, and that's $2,800. Okay, so calculate the interest earned. The interest earned is $2,800. Now the question is, part B of the question is rather, what is the future value of Bob's investment? Well, the future value, the future value, we can use either A or FV, it's the same thing, is equal to the principal we invest plus the interest that we earn. So we invested $8,000, we earned $2,800 of interest. So the future value of Bob's investment is $10,800. Okay. So that's it for part A. That's pretty much it for simple interest. They call it simple interest because it's pretty simple. I mean, actually that's not why they call it simple interest, but it's a happy coincidence that simple interest is a simple thing to work out. All right, we're going to get rid of the solution over here now for question 1, and we're going to look at question 2, where Mary's got her money compounding. Righto, so Mary's investment is $5,000 at 6% per annum. It's compounding interest for 4 years. We want to calculate the interest if, we want to calculate her future value, sorry, if her interest compounds annually. Well, what's our formula? Our formula is that our future value is our present value, it's sort of 1 plus r to the power of n. Okay, what's our present value? Our present value is the money we're stumping up at the start. It's $5,000. Outside of 1 plus r, our interest rate is 6% per annum. So we've got to write that as a fraction or a decimal. So 6 over 100 to the power of n. N is 4 years. Now, look at this. I haven't changed anything. I haven't done anything to my 6% or anything to my 4 because my question tells me that I'm compounding annually. Annually. That means I want my interest to be annual, per annum, per every year. It's 6%. 4 years. This is speaking about it like a number of annums, if you pardon the little Latin sin that I just committed then, right? So 4 years is four, like in terms of the annum there, the annual, 4 years, they all agree. So R and N agree. I don't have to do anything, I don't have to change anything, I just literally put my numbers straight into my formula. And then from here, it's just a matter of getting my calculator and entering values. So I've got 5,000 times 1 plus 6 over 100 to the power of 4. Right, now, I very strongly suggest, guys, I know that not all of you have natural display calculators, but life is honestly a heck of a lot easier. I don't know if that'll come up on camera or not. Life's a heck of a lot easier. Come on, focus for me, please. Yep, okay. Life's a heck of a lot easier if you can get a natural display calculator where you can put, your exactly what we see there is exactly what we have on our calculator, so we know that we're getting it right. Our future value is $6,312.38. Now, we're talking about money, okay? It's a money amount, so please give either to the nearest dollar if that's what the question asks for, or if it doesn't, please give to the nearest cent, okay? Don't give one decimal place for money. Nobody speaks that way, okay? You don't go to a shop and say, look, how much for a pie, and have the person say $4.2. Nobody speaks that way. $4.20 is what we say. Right? Give 2 decimal places if you're talking about money. Right, let's press on. So in part B, we're told that our interest is compounding monthly. How would we set that out? Okay, so I'm going to write my formula. Future value equals present value outside of 1 plus r to the power of n. And then I'm going to do some work to make 6% per annum monthly and 4 years months. Now pay very close attention to how this happens. So my rate is 6% per annum. So ask yourself, how many months are there in a year? Well, there's 12. So 6% per annum is 6 divided by 12% per month. Now remember, my interest rate cannot be a percentage. It's got to be a fraction or a decimal. And you're sitting there saying, oh, Mr. Obeid, that already is a fraction. Well, that is a fraction, but it's still a percentage. The percentage sign is still there. I need to change this percentage into a fraction or a decimal. Okay. Look, you don't need to simplify fractions at this point. So a very easy trick, I mean 6 over 12 is pretty easy to simplify, it's a half. But let's pretend we didn't know that, or let's say it was something nasty like 7/12, where we couldn't easily cancel it down. It doesn't matter. Leave it as 6/12 in compound interest questions. It doesn't matter. So leave it as 6/12. How do I change 6/12% to a fraction? Very simply, watch. I just stick 2 extra zeros in my denominator. And now I've changed the percentage into a fraction. Okay, keep that little handy trick on tap, guys. So 6/1,200 per month. Notice there was a percentage sign there, there's a percentage sign there, and there's no percentage sign here because I've converted from a percentage to a fraction. No more percentage sign. Now what about n? Well, n was 4 years. Well, how many months is 4 years? Well, if you think about it, how many months is 1 year? Well, 1 year is 12 months. 2 years would be 24 months. Well, what are we doing? If 1 year is 12 and 2 is 24, what are we doing? Well, we're multiplying by 12. 3 years, 36, 4 years, 48. We multiply by 12 to go from years to months. Look, for the interest rate, to go from 6% per year, to get to per month, we divided by 12. To go from years to months, we multiply by 12. Make sure you understand the distinction. Ask me about it if you're struggling with it. So 4 years is 4 times 12 months, is 60 months. So now I can come along and I can put these numbers into my formula. Okay, I'm going to clear up what we did up here in part A, so just so I can continue my work up the top of the page. Okay, so our future value is going to equal our present value. That's the amount we're investing, which is $5,000. Outside of 1 plus our rate is 6/1,200 to the power of n, which is 60. And so once we've got that, we now go to our calculator. Okay, that's going to equal $6,744.25. You'll notice that this is significantly more than when our interest rate compounded annually. Okay, so a good little tip for yourselves, you want to find for an investment, you want the shortest compounding periods possible. So when it was annually, and obviously a year is a heck of a lot more than just a month. So if you can make an investment with the interest compounding annually or even daily, that's better than interest compounding monthly or quarterly or 6 monthly or yearly. So the shorter the period, the better. Okay. So guys, that's an example of simple interest that we've seen, an example of compound interest, a compound interest example where we had to make R and N agree with each other. Okay, we had to change them both from years to months. Okay, that's all you need for exercise 3A in our textbook. So go to exercise 3A, have a go. I've got all the confidence in the world that you'll be okay with it. Don't let any sort of difficulties or confusion stand in the way of you working hard, seeking clarifications. Ask questions. If there's anything you struggle with, ask me about it. Drop a question in the comments below, or shoot me a comment over in our Microsoft Teams page. However it works for you guys, just make sure you're doing the work and you're getting all the help that you need. Thanks very much, guys.